So in problem number 30, we can recognize that we have a quadratic equation, and in quadratic equations, typically they're going to be factoring, so we want to gather all the terms to one side. Oops, minus 6. So we want to subtract 13x and subtract 6 from both sides. So you may remember this from Algebra 1 and then Algebra 2. We're going to solve a quadratic equation. Solving quadratic equations, like I said, in general, we want to try to factor the left side here. And if it doesn't factor, we're going to have to use the quadratic formula. But most likely it's going to factor. In factoring the left side, we notice that the FOIL method, we want to multiply the first times the first to get the first term. And there's only one pair of factors for 5x squared, that's 5x and x. Now, a little bit of creativity here. We've got factors of 6 that are going to add up to 13, or that are going to have a difference of 13. So actually, I take it back. Factors of 6 are 3 and 2 or 6 and 1. Normally, we're going to try the 3 and the 2 first. And if we put the 3 there and the 2 there, we're going to have the outsides is 15, the insides 2. 15 and 2 can make 13 if we put the minus sign and the plus sign in the right place. So if we put the minus sign there, that gives us negative 15x. So if we're figuring out what's the outside, what are the outside, one more time, when you multiply the outsides together, we're going to get negative 15x. And when we multiply the insides together, we're going to get positive 2x. Well, we have to quickly check that, and that's going to be negative 13x. Check, and that's going to give us all three terms. So that is the way to factor that trinomial. And I find a lot of students kind of have forgotten how to factor a trinomial when the first term has a leading coefficient that's different than 1. So in other words, if we take away the 5, usually students have an okay time with that. But as soon as you put a number besides 1 in front of that x squared, it becomes a more difficult problem. But like I just did, I showed you, there can be a pretty quick way of finding the factors. But anyway, once we find those factors, we set the factors equal to 0, and we solve for x, and we get x equals negative 2/5, and over here we get x is equal to 3. So probably the most difficult part of that whole thing is factoring the left side, but please know how to factor a trinomial that has a leading coefficient other than 1. That's a big deal. So graphing this, or using our graphing calculator to solve this problem, we're going to let our left side, the 5x squared, be our y1, and then our 13x plus 6 is going to be our y2. Notice that we're going to set a quadratic equaling a linear, and that's okay. Again, do zoom 6, get the standard viewing window on your screen. We're going to quadratic equaling a linear function. So we're going to have to do some adjustments here, because we know that there's two solutions, because we know that we see the red graph being a line intersecting the blue graph being a parabola. Parabola is going to catch up to that line, but it's going to catch up to it way up there. So we want to make sure we adjust our window. We saw that somewhere in between negative 5 as well as 10, let's say, let's let that be a 5. So we're going to adjust our window. We want to get good at this. The y min is going to be no lower than 0. And then the y max, though, this is the big one here. Let's put that all the way up to 50. And here's another little tip for you. Change the x res to 3 so it draws the graphs faster. So there we have, maybe we lower that y min a little bit lower to negative 10, let's say. And so we can see clearly the two intersection points. So when you adjust the viewing window, you have a better idea. And we go on to do second, calculate, intersect, hit number 5. First curve, blue curve, second curve, the red one. And then move the cursor over to the left a little bit to find that x equals negative 0.4. And remember, we found negative 2 over 5. Well, 2 over 5 is 0.4. So we found the first one. When x is negative 0.4, we found the first one. Let's do it again. Second, calculate 5 for intersect. First curve is the blue curve, enter. Second curve is the red curve, enter. Now let's move the cursor over to the other point of intersection and hit enter, and we find that when x is equal to 3, the two sides are equal. The y1 is equal to the y2. So we found two solutions. X is negative 0.4 and x is equal to 3. We found that by hand, and we found it on the graphing calculator.